let's have a look at how to display results from running IRPM on a well log. We are still working with our Calibrate model project, and down here we have 4 IRPM on well log runs that we have done. So let's start displaying some results. To display the results, you open up the run and then you right click on the output folder and then choose Display Solutions. This opens up this window and you can choose a preset that we can modify. We need to specify the logs for the effective porosity, volume fraction of shale and water saturation so that we can plot the log values together with the solutions to compare with. After having done that, we save this as a new custom template so that we can easily reuse it at a later time. So I call it well A. And then we just run this. So this is displaying the solutions for the specific solution types that we did. And what you see here is 3 well log curves, one for the effective porosity, one for the volume fraction of shale, and one for the water saturation. The black line is the well log values, and the color dots are the predicted IRPM solutions. The color value here is the model likelihood, so how well does the data and the model match each other. A red value means a high likelihood, and a blue value means a low likelihood. Where there is no colored dot plotted means that the likelihood is below a threshold. So we are saying that there are no solutions there. What we plotted now was the solutions in case of acoustic impedance and VPVS ratio as input. Now let's look at the solutions if we also include the density as input, so 3 input properties. And here we see the results, and what we notice right away is that the variance has been reduced. There are fewer possible solutions. So we have a better constrained predictions, and we see also that the match is quite good with the log, especially for the porosity and the volume fraction of shale. The water saturation is more problematic, and that is a typical thing. Now you see here that you can change what the color value should be. We are here changing it to depict the water saturation, and you can also change the color palette that you're using. The clue here is that there are many possible solutions for one sample, and the predicted values for porosity, volume fraction of shale, and saturation are all linked together. So one value or one prediction for the porosity is matching another prediction for the shale and the water saturation and so on. So if we inspect this a little bit closer, we see here a value of 32% effective porosity, very low amount of shale, and for the water saturation it's also a high amount of hydrocarbons, so little water. This is from the log, and if we click here on the predictions we can inspect the solution space for this. So this is similar to the model space that we saw for the IRPM models, but what you see in the top left corner is extracted surface using the first input property, so the acoustic impedance. Top right plot here is for using the VPVS ratio, and the bottom left is for using the density. So again, the color code here indicates the likelihood, and we can see that we have some areas or large areas with blue, low likelihood, and then we have some region with higher likelihood. The bottom right plot shows all of these surfaces combined together. So that is the final solution, and that is much more constrained. So that is our final solution that we have plotted in the other log plots. If we take a closer look here, we also see that the axes here are a little bit different from the other plots. It's not going all the way, so it's focused on that upper region, basically. A challenge with all these possible solutions is how to present them in a good way. Like here, we are looking at one sample and we are spanning out the whole solution domain. And before we were looking at all the log samples and we were plotting the different solutions along the x-axis. But for example, if we are going to look at seismic, then we are going to use the x-axis to plot inline or crossline. So we cannot use that dimension to depict the different solutions. And what we need to do then is to generalize in some way all these possible solutions. And here is a challenge. What kind of single sort of solution would you use to describe all these possible solutions? What we have done then is in the general IRPM run, we have several solution types that we predict. So let's have a look at that. We are going to display the results. The panel here is a little bit different, but it's not that much different to begin with. We choose a template that we modify. We specify the effective porosity, volume fraction of shale, and water saturation so that we have that log data. And then we need to specify which solution types do we want to plot. For example, the most likely estimate is already there, and then we're adding the mean value. And we are also going to include the standard deviation, and we're adding the weighted mean value. So this is the mean value weighted with the model likelihood, and we are also going to plot the posterior mean. And we are going to change this a little bit so that we are plotting in separate windows. You can also add statistical solution types, and you can also mask the solutions, so only plotting solutions for a certain volume fraction of shale interval, for example. Here are the results, and they are plotted in several displays. This is the most likely estimate. The black curve is from the log, and the colored curve is from our predictions. And that filled area around the colored curve indicates the interval between plus and minus the standard deviation. And then we have the mean value, and then the weighted mean value, and finally the posterior mean. So the posterior mean is from the Bayesian type of IRPM, where we have used the a priori probability specifications that we did. So using these solution type plots, one can start to interpret the data. Now this was again looking at just two input properties, and here we are going to also display the results when we use three input properties. I forgot to save the template, so I have to go through this process again of specifying these things. But after having done that, again I can then just save this template for easy reuse at a later time. These templates can also be exported and imported from different projects. So we proceed plotting the solutions here. And we're going to compare the most likely estimate using 2 and 3 input properties. So this is using 2 and this is using 3. Again, we see that the variance has decreased and we are getting a pretty good match here with the log data. And now for the mean value, which does not take into consideration which solutions are more likely than others. And then we have the weighted mean, and finally the posterior mean. So the posterior mean, if you apply an a priori probability related to the saturation, you're probably going to get a better saturation prediction using the posterior mean. And again, we had the report running in the background, so our results are also put into the PowerPoint report.